your name?
Malin.
Which one?
Malin, right there, the third
Malin?
one. Yep.
Yeah. You want this recorded? When it's recorded, you go to the web page over there.
Oh, sure.
Your pen pad.
There we go. Malin ICUC10.
This one.
I thought you wanted a PDF. We could do the PowerPoint.
Yeah. You have some notes in it.
I have a few notes. I don't know if I'll need.
Good morning, everyone. Welcome to Thursday morning. We'll have some public type announcements at the end of this session, but I'm Jamie Vood. I'm the chair of the morning plenary, and today we are welcoming Dr. Alan Bloomberg as our plenary speaker. Dr. Bloomberg is currently with Jupiter, a private sector company that focuses on risk and prediction related to environmental hazards, including climate change. And Dr. Bloomberg was formerly the George Meade Bond Professor and Director of Davidson Laboratory at the Stevens Institute. Dr. Bloomberg describes himself as an urban oceanographer, and he studies the interaction between coastal waters and the adjoining urban environment. So he's worked with observing systems and also forecasting systems, and was one of the developers of the Princeton Ocean Model, which has been widely used around the world. So he's done a lot of work on the interactions between urban areas and coastal systems locally here with both New Jersey and New York. And so I think he's a great example of a speaker to talk to us about urban resilience in the context of climate change, and particularly in the case of the type of events that New York City has experienced. So, without further ado, Dr. Bloomberg, welcome to ICUC10, and we look forward to your presentation.
Thank you, Jamie. It's a real pleasure for me to be here today because I'm at the bottom of your boundary layer. I am the ocean that sits on the bottom of everything that you study, and I'm thinking about the urban part of your domain, and I look at studying the interaction between water offshore of an urban environment and the urban environment's effect on the water. So it goes both ways. Let me give you a sense of what the urban ocean is all about. So the urban ocean is where we live. Half the people on Earth live in the urban environment where there's water offshore, 50%. So you keep that number in mind, you understand how many people there are on Earth. Half live near the coast. And 80% of the United States population lives near the coast. Of the 23 largest cities in the world with populations of larger than 10 million, 18 of them are on the coast. So the urban ocean is where the ocean, the land, and the people all interact. Now I'm going to give you some challenge in the next few slides, and I need your participation. So where is this urban ocean? You notice there's a big city, there's water, and there are people in between. Do you know where this is? We can't go on unless I have participation here. Okay, I'll give you the first one. Honolulu, Hawaii. A big example of an urban ocean. So let's do another one. You know where this one is? Qingdao in China. Very similar to Shanghai, that's for sure. Another one? Absolutely right. Hong Kong Harbor. And what do you think this place is? I hope this is a given, right? This is New York City, of course. Huge infrastructure at risk to a changing environment, to events that happen offshore that move onto shore. We have a new norm in this world. These are the rescue team that had a lot to do with Hurricane Harvey when it impacted the city of Houston in Texas in the United States. The new norm is all about a disruption, and it can be very frightening to a lot of people. But that doesn't mean it's not happening just because it's scary and frightening. A lot of times the discussion you hear about is what's going to happen in 50 years, in 100 years, in 500 years. But that's really irrelevant because a lot of it is happening right now. You have data. You have papers that appear in journals and newspapers that tell you now is a critical time for all of us. This is a video animation that was put together by the New York Times in the aftermath of Hurricane Harvey. Last year, in 2017, there were 3 100-year events of precipitation in the United States. 3 in 1 year when you should have 1 in 100 years. And you can see here before and after of what happened in Houston. Really scary what can happen in a few hours during a big event, a big rainfall event. So this is really a catastrophic kind of event that you really have to worry about. But there are other kind of events that happen every day. You don't have to wait for these big events. This is a graphic put together from data provided by NOAA. On the vertical scale are a number of important cities along the eastern coast of the United States. And what you see across in time from 1920 to 2016 are the number of days per year when there was nuisance flooding occurred. So what's nuisance flooding? When high tide gets a little higher than usual and water comes onto the land, and you have to drive to work in salt water, right? And you can notice to the right of this, the bright colors are incidents that are happening more than 10 times a year. And when do they occur? They occur mostly in the last 15 years. Before that, they were not occurring very often. The dark blue are lower events, 2 to 4 a year. But you certainly can see when the bright ones occur in the last 15 years. So that gives you a real sense of what's happening in the environment, right? And also, we have temperature increasing on our planet. And this is a very cool graphic from Ed Hawkins, a British climate scientist. And what he shows in his graphic is on the horizontal scale, it's the last 100 years. And the color is how hot the temperature has changed in that 100 years based on a baseline from 1850 to 2017. And where is all the heat? Is it now? This kind of graphic has permeated everywhere in the AMS, for example. AMS sells ties with these colors on it. I've seen cars with this on the side. So you get a real sense that things are changing, both in terms of nuisance flooding, in terms of heating, in terms of sea level rise, all happening at the same time. So this is the key point that we have to consider as we move on. We live in a world designed for an environment that no longer exists. So you scientists have to figure out a way to make our environment more habitable for everyone who lives on this planet. Where there's 7 billion people going on 10. So there's a lot of thinking that needs to be done as we go. So our new norm must recognize a number of features in terms of the urban ocean. And one, we have to understand that the urban ocean is very unique. And I'm going to show you some of the properties in the water of what happens offshore of a city. Number two is what we must recognize, that the influence and impact of temporal and spatial resolutions or variations from seasonal to millennial timescales must be viewed, and we need to understand how the catastrophic events occur as well. And finally, the influence and impact of human interactions through all kinds of things we do to the environment, land degradation, river management, climate change, and other activities really must be considered as we go forward. So these 3 norms must be factored into what we think about in time. So how can we, the urban ocean, hydroscience, and weather community, address the risks and impacts of this changing climate? Well, we need to have new data, and we have to have new models that understand how to use that data and make predictions that we have confidence in as we go forward. We need to understand the urban ocean's dynamics, chemistry, and biology. We need to foster innovation to focus on the interaction of water and the urban environment. A city could easily build a jetty or a breakwater, and that could change the entire circulation patterns in the coastal ocean, which would have dramatic effects on the weather of that city, because as storms move across the water onto the city, the water has a profound influence on the weather event and on the city itself. So let's talk about new models for a minute. Do we know who this is? In 1687, this guy said, I know the equations of motion. Now, our problem is we don't know how to solve them very well, but we're learning as we go, right? So we need new models. I needed to put these equations up for you, because how could I give a talk without having these equations? So Isaac Newton gave us these equations. We need to figure out how to solve them better and faster and more robustly as we move forward. 1687, interesting. We need to figure out how to use data. These are data that we've put at the end of JFK Airport runway, because the airports want to know when they should close when a hurricane is coming or a nor'easter. And the best way to understand it is to have water level data in the location. So here are these two vertical columns. These white vertical columns are water level sensors, and of course, sensors that measure temperature and salinity. Now, I have two of them, you notice. And why? It's because if one goes bad, we have a backup